Okay, we're still in section 3.1, tangents and the derivative at a point. So right now what we're doing is we're providing this definition. It's actually some new notation. So this looks the same, right? The limit as h approaches 0 of f of x naught plus h minus f of x naught over h. So we've talked of this as being the limiting value of secant lines. And now we're going to denote that. And whenever we write this notation here, with f with an apostrophe of x naught, we read that as f prime of x naught, so f prime of x naught. That's just notation for this guy, and it's actually the definition of what's called the derivative of this function f at the point x naught. Now, there's a bunch of interpretations for the derivative, okay? So remember, way back in algebra, you were asked to do this difference quotient many times, and now you can kind of see why, because we want to take the limit of that as h approaches 0, and then we've gone on further now to give that a shorthand notation of f prime of x naught. And all these interpretations, there's four of them here. The slope of the graph is the slope of the graph, or the slope of the tangent line, same thing. The rate of change of the function with respect to x at x equals x naught, or simply just the derivative, f prime of x naught. Okay, so all of those mean the same thing. We should always think of the derivative of a function as the slope of its tangent line at a specific point, whatever that point is, in this case x naught. Okay, so for example 25, let's do that with a particular function. F of x is x squared plus 1. We want to find the slope of the graph of this guy. In other words, a slope of the tangent line to this function at the point 2, 5. So you need to identify that x naught is 2. It's the x value in your point. Then find an equation for the line tangent to the graph there. Okay, so f prime of 2, find the slope, f prime of 2, x naught is 2, is the limit as h approaches 0 of f of x naught plus h, so 2 plus h, minus f of x naught, so f of 2, all divided by h. Once you have that plugged into the definition, it's just a matter of algebra at this point, and then eventually evaluate the limit by plugging in h equals 0. So just be very careful when you simplify here. You have to know what f of 2 plus h is. You take 2 plus h, you stick it into f of x everywhere you see an x. So 2 plus h quantity squared plus 1 minus f of 2, stick in 2 everywhere you see an x, 2 squared plus 1. Multiply all these things out, so you got to FOIL 2 plus h to get 4 plus 4h plus h squared plus 1 minus 4 plus 1 is 5. So, and then cancel everything. Everything that doesn't cancel should have an h in it, because you're eventually going to have to cancel the h in the denominator with an h that you factored out in the numerator. You can see how that works right there. So this all simplified down to taking the limit as h approaches 0 of 4 plus h. Plugging in h equals 0, you get 4. So the equation of the tangent line at x naught equals 2 is, by using the point slope form for the equation of a line, right, y minus y naught equals m times x minus x naught. So your m was 4, your x naught, y naught were 2 and 5. So y equals, then you can simplify this if you want to put it into the slope-intercept form. Y equals 4x minus 3. And I just drew you a picture over here so you could see what you were doing. At the point 2, 5, you were finding the slope of the tangent line by finding the derivative, and then you found this equation of the tangent line by using the point slope form.